So RESTful APIs.
Welcome. Today I want to talk about what an API is and why it's important in web development. API stands for Application Programming Interface, and basically it's something that allows one piece of software to talk to another. Now there's lots of different kinds of APIs, but when you hear people talk about Twitter's API or Google's API, what they're talking about is a REST API. And a REST API stands for Representational State Transfer. Now, it doesn't have to be the case, but usually a REST API works pretty much the same way a website does. You make a call from a client to a server, and you get data back over the HTTP protocol. Now, I think one of the best ways to show the many similarities between a REST API call and loading a normal web page can be found with Facebook's Graph API. For example, let's pull up YouTube space www.facebook.com/YouTube. And we're all familiar with what a Facebook page looks like. It shows how many likes the YouTube page has, things like that. But now let's change the www part to graph.facebook.com/YouTube. And what we get back is a response to our API request. We've made an API request in our browser to Facebook's Graph API. Now what we get back might appear to be gibberish to the human eye, but it's actually JavaScript object notation or JSON formatted data. It's structured data organized according to key value pairs. The same way an Excel spreadsheet is structured with key value pairs, and you might ask for the data that's in cell A16, you can ask a JSON array for the data if you want to know how many likes this Facebook page had, for the data contained under the key likes. And all modern programming languages will be able to interpret this JSON response. One more concept I want to introduce is the idea of parameters. Let's reload that same Facebook API request, but this time let's add fields equal ID, name, and likes. Now when we refresh the page, you see that only ID, name, and likes have been returned. That's because these parameters have filtered the data that we get out of this response. Now let's take a look at another API example. One that I think is really cool is provided by Google Maps. It allows you to take a city name or even an address and turn it into a set of GPS coordinates. guys.com/maps/API/geocode/JSON. So if you remember what we just talked about, the server that we're calling is maps.googleapis.com. And then the particular resource we've drilled down. It's the maps resource, and then the API resource, and then the geocode resource, and we've even added JSON as a resource. And that's because the Google Maps API can return data in a number of different formats. And then we'll add the following parameters. We'll add address equals Chicago and sensor equals false. And as you can see, we got another JSON response. And if we look in the JSON array and we go to the key results, and then the key geometry, and then the key location, we see the latitude and longitude coordinates for the city of Chicago. Now that's great and all that we got the geolocation coordinates for Chicago, but what do we do with them? Well, let's mash two APIs together and take those geo coordinates over to Instagram and plug them into Instagram's media search endpoint. So in order to access the Instagram media search endpoint without having to write any code, we're going to head over to instagram.com/developer. And then on the left-hand side, click on API console. And we'll be able to use this API console that's provided by API or Apigee in order to make requests to the Instagram API without needing to write any code. And you can see if you click on the drop-down on the left, there's a whole bunch of APIs that this thing is set up to allow you to play with. But for now, we're going to use Instagram, and we're going to be using the Instagram media search endpoint, which you can see is at api.instagram.com/version1v1/media/search. And then we're going to set the following parameters. And you can see that they're added to our URL request up at the top of the screen. We're going to set lat equal to 41.87 and longitude equal to -87.62. And we'll set a distance of 20 meters. We click send, and we get back this information about our request. We see it's a GET request, and it shows where it was sent and what parameters we passed in. One of the parameters that we didn't set was the access token, because that was automatically set by the Apigee interface. And then below that, in sort of the blue and purple, you have key value pairs of headers that we've sent as part of our request. And then if you look over at the response, you can see we got an HTTP status code of 200, which means success, that everything went okay. And then there's some header information as well. We've got X-rate limit, which is 5,000, which is the total number of requests you can make to the Instagram API using one access token during one rate limit period. And then down below, you can see X-rate limit remaining, which is 40,994, which is how many requests we have remaining in this rate limit window. And then there's some information about cookies and content type, application JSON, things like that. And then if we scroll down, we'll see the body of the response, which is a JSON encoded array of all the images that match the geocoordinates that we passed in. And there's information such as what filter was used in order to take the Instagram picture, how many likes it received, how many comments, information about the user who posted it, how many followers they have, things like that. And then of course there's also the images themselves. And if we copy that image link, we take it up into our URL browser and we paste it in, then you can see there's a picture from that location in Chicago. You can even see the Chicago skyline in the background. Pretty cool, right? There's literally thousands of APIs out there that you can tap into and take their data, mash it up, pass it to another API. Chances are, whatever website you want to work with, they have some kind of API that you can use in order to consume their data. APIs that are available. Check out programmableweb.com. Until now, we've only been consuming data from APIs, but you can also write data to APIs. So before we go down that road, we need to talk a little bit about the concept of HTTP request methods. I linked the documentation in the description below, but the big two that you really need to know are get and post. Now, a GET request is what you consume data, and that's what you've seen us do so far by passing these URL parameters in order to get data back from the API. But a POST request for writing data to the API, the best practice is to actually put the data in the body of the request. Now, a normal web browser doesn't allow you to put data in the body of a request, but what you can do is you can install this handy extension called Postman REST client. The nice thing about working with Postman is you can make more complex API requests. For example, you can choose any one of the available HTTP request methods, and you can see a list of them here. Second, you can add a body to your HTTP request. And finally, you can add headers. So let's use the Postman client in order to send a tweet out over the Twitter API. Before we do that, though, let's talk briefly about the concept of authentication. Obviously, you need to give some kind of authentication if you're going to be sending tweets out, because otherwise you could send tweets from my Twitter account and I can send tweets from yours. And what a lot of these big online websites are using for their authentication is what's known as OAuth or OAuth 2. Let me just say briefly, basically what you're doing is you're getting credentials, kind of like a username and password, although they're called a client ID and a client secret. And then you're exchanging those for what's known as an access token. And then you pass that access token to Twitter, and Twitter knows that the request to make the tweet is coming from you, so it sends out the tweet from your Twitter account. Okay, so let's go ahead and send out a test tweet using the Postman REST client. We'll select post as our HTTP request method. And then you'll see that the server we're accessing is at api.twitter.com. And then as we drill down to our tweet sending resource, we are at version 1.1 of the Twitter API, and then /statuses/update.json. And again, that tells the Twitter API that we want JSON formatted data as a response. And we've set the authorization header to our OAuth 1.0 credentials. And then down in the body of our post request, we've set the key status to test tweet from Postman. And when we click send, you'll see that there's information about what time the tweet was created, the tweet ID that it was assigned, information about my Twitter account, the Twitter account that the tweet was sent from. And then if we click over on my timeline and we refresh the page, you'll see sure enough that the test tweet we sent out shows up.
All right, so that was a lot of things to to take in just a few minutes. All right, so now let's slow down a little bit, back up, and let's go over this. Well, not the whole thing, but some of those things again. All right, so what are RESTful APIs? Well, that's exactly the video we just watched, so I'm not going to go back there. Now, there are, so first of all, the RESTful APIs are used, well, by, depending on the estimate, some around 90% of all the APIs we have are going to be RESTful or REST APIs. That is the most popular type. So, for example, your cell phone, right? When you're using, if you're using your cell phone and your cell phone stores data on your cell phone, yeah, some of it, right? But think about it. How many of your applications that you're using actually, when you store data on it, it actually stores them in the cloud, you know, where the unicorns live, and all the problems are solved by just purchasing more computing power, because that's what the cloud is really. Well, yes, your phone has a copy of the data, but then the actual storage of the data for many of the applications that you have is actually on some sort of a server in the cloud. right? And guess what? Storing data and retrieving it is exactly what RESTful APIs do. That's why most of those applications on your phone will actually be using RESTful APIs. Desktop software also uses RESTful. There's no problem with that. They absolutely do. And for our purposes, for the purpose of this course, we will actually create a client in JavaScript. It's actually planned for today, tomorrow. Today we're just going to focus on the server, and tomorrow we'll look at the client side. Well, depending how time goes, maybe we'll do some of the client today. We'll see. So you need two parties there. There's a server and there's a client. And what RESTful APIs really do, they do CRUD, right? They allow you to create, retrieve, update, delete data. And I know what was shown in the video is a little overwhelming because these are big APIs. These are, the kind of size that you create over many years once you figure out all your needs, and you have thousands and thousands of hours of work put into them. And yes, they are extensive, right? But the basic idea of RESTful API is to create, retrieve, update, delete records. That's all they really do, plus authentication. So usually at least when I started to learn about it, I asked myself, hold on, why would I need an API? Why can't I just connect to a database? Right? Just like what we did in the .NET desktop projects, right? We had a database, we connect to the database, and you can do CRUD, right? You run your SQL queries. So why on earth would you need an API? Good question. There's a few reasons. First of all, resources and internet connection. You see, when you open a connection to a database, you have to keep it open, right? You wouldn't be opening, closing, opening, closing, opening, closing. You keep it open, so you have to be connected all the time to the database. That's one issue, right? So on cell phones, mobile devices, you see their biggest limitation these days, as cute and smart and fast as they are, their biggest limitation today is the battery. I mean, we have to charge them every day, right? That's kind of how they work, right? And I was actually looking at just kind of imagining, getting myself the wristwatch from Apple, right? And I'm thinking, okay, well, I haven't actually had a watch since a long time. I just don't really need it. But if I did, what would I do with it? And one of the main things that actually turned me off is that you have to charge it every day. I'm like, not only I would have to buy, so if I buy it, not only I have to buy charge my cell phone every day, but now I also have a second device to play with. So I have to remember to charge my watch every day. I mean, seriously, I have better things to do in my life. So, and plus the price is kind of crazy. But anyway, so the biggest limitation on mobile devices is really the battery life. So the problem is that if you're keeping a connection open to anything all the time, it drains the battery. And there is a lot of functionality in the operating system of your cell phones, something called push notifications, where the cell phone's operating system has a way of contacting the servers and getting notifications from them with a minimum use of energy. So yes, they do keep a connection open, but it's done in such a way as to minimize the actual use of the battery life. So that's one of the reasons, but it's not the main one really. The main reason of why you need an API instead of actually writing SQL queries is this. It gives you control over who is allowed to do what. Think about it this way. In the previous project, right? So you did your desktop ASP.NET application. You had to actually embed in the application the username and password to access the database. What if somebody got the same username and password and wrote their own app? Because they could extract it, right? They run their own application. They connect to your database using the management studio. What can they do? They gain access to all the data, right? You have no control over that, right? In other words, you essentially are opening admin access to everybody to the entire database. Now, it may work. You see, if you are in control of all the machines, that this may work actually pretty well. My first paid programming job was actually for a company that was creating enterprise level software. And what they did, they had a machine with a database, right? And then they had clients connecting to it. And that worked actually pretty well without any sort of fancy APIs. That was, we're talking about 1990s here, so late 1990s. So computers were about 10,000 times slower than what we have today. So there was no way of doing any APIs back then. No, not if you wanted the system to remain reasonably fast, right? But that was not an issue because we trusted all the machines, right? There was no evil people or bad actors, as we call them, right, trying to break into our system, right? So we could install our piece of software, the client, on all the workstations. All of them, each of them had access to the database, right? And they would use it. There was no need for access control. But on the web, that is not the case. We already said, never trust the client. You cannot trust the client if it's a mobile device. You cannot trust the client if it's over the web, if it's a web browser. You can't, right? You have to always verify, right? So imagine, for example, that you have an application. We're actually going to do that one as a demo. Let's say you have an application to do. Anybody has a to do application? I used to have, it was called Wunderlist, right? And now they actually were bought up by Microsoft. They're called Microsoft To Do, right? So it's a to-do list essentially. I use it for shopping and other things like that, right? So I don't have to. So when I go to the grocery store, I know, which grocery store or which store to visit and for what exactly. And think about it this way: I'm not the only user of this application, right? The data, yes, of my application, there's a copy of it. There's a cached copy of it on my phone. That's true. But the main copy of the data is on the server. Now, I'm not the only user. There's probably millions of other users, which means I cannot be given a password, username and password to the SQL database where I can actually potentially access my data and then data of millions of users. Absolutely out of the question. You can't do that, right? So what do you do instead? You use an API. So my device here I have to register an account. So I got my user and password so I can authenticate. And then through the API, I can access only those records that I myself have created. Now, the database table or tables as they are there, they exist for all the users. I'm not the only user I don't have my own table probably, right? Or my own database. I don't, right? There is a table and one of the table fields is owner ID, right? And I only have access to those records where I am the owner of the record. But you can only do that if you have an API. Okay, so that's why all those systems, such as mobile devices, websites, and even desktop applications, they are based on APIs, especially in the times of cloud. Think about your Microsoft Office, right? If you install Microsoft Office these days on the desktop, it actually communicates with a server to store your documents in the cloud too, right? Or fetch some other information. Now, their use of APIs may not be as extensive because they are doing things through OneDrive, right? So it's a little bit different, but still, there is. I'm sure there's an API there. Okay. Any questions of why we need RESTful APIs at this point? If you do have questions, I'll take them gladly. Anything that's still not clear on why, not how, why. Yes.
What is the difference between REST and full REST API?
Between REST and what? And
full REST.
I never heard of full REST. RESTful.
Okay, RESTful.
RESTful. Oh, it's the same thing. It's just kind of two different ways of saying it. Yeah. Just because people, when you say REST, people get confused. They think about resting, like I'm gonna rest, right? So they started calling this RESTful API. There's no real other reason for it. It's the same thing exactly. Yeah. REST and RESTful is the same thing. All right, the second type of APIs, which you may encounter sometimes, that is more rare that this happens, I actually use those, are remote procedure calls, RPCs, where you're not just performing an insert, update, delete, or fetching of the data, like you're doing with the CRUD or RESTful or REST, right? But rather you're calling a method. So for example, if I have a server that is doing, let's say, video encoding or audio encoding, right? So I send a stream of data and I'm saying, hey, this data is in, let's say, a MP4, right, container, and I'd like you to convert it to AVI. So I send it the data. It's a procedural call. It's like a call to a function or a method, right? It's a different type of APIs. You guys actually have a course late at the end of your program called Web Services. When I teach this course, I usually teach it there. we actually show you a couple of types of remote procedural call APIs. They actually are very useful, just not for what we're doing this course. Okay, so you're calling a method. Server has a method, you can call it, or server has a bunch of methods, you can call it from the client. There is usually authentication involved too, because we want to, make sure that we know who the client is. Absolutely, right? But those are a minority. Those are a minority. I would say up to 10% maybe of APIs in the world, maybe less, use that. There is quite a few of them. There's JSON RPC, XML RPC, SOAP, and .NET has something called web services, which is the best of them all, actually. And as I said, I usually teach all of those when I teach web services course. I do not know what is going to be covered exactly with a different teacher you're going to have, but I mean, you'll see. Okay, now forward here with the RESTful. Guys, authentication, let's talk about this one. So authentication is often used, done using OAuth 2.0, open authentication. It's not by itself part of the RESTful standard. REST doesn't define any specific authentication method. You can actually, I can think of at least 4 ways of doing authentication with RESTful APIs. Any of them is okay. And I'll show you one rather simple way of doing authentication. We'll actually do that. Okay. RESTful also does not define the type of data that can be sent and received. Now, in the video, you saw textual data in JSON, right? Which is the JavaScript object notation. And it's nice for data, but the RESTful APIs, they don't define any specific format. So if you want to do XML, you can do that. If you want to do binary data, let's say send a picture, receive a picture, you can do that too. We actually do that occasionally. Different calls can actually send and receive different types of data. One call could receive JSON, another call could receive XML, another call to a different URL could receive binary data, and that's okay, right? RESTful APIs, RESTful allows you to choose which type of data you want to send and receive. All right, now the URLs. So before we get any further, I want to look at, there is this really nice link here. We already saw this one before with HTTP status code. Let's talk about those for a moment. And also we need to talk about the HTTP methods actually before that. Guys, so far, let's talk about the HTTP methods. So far, you know about get and you know about post, right? So if I type a URL in the web browser and I press enter, that is always a get, right? The request is always a get. If I look here, if I look at, actually not here, I'll inspect here and I go to the network, refresh this. There you go. Here's a get, right? If I go to my headers, you see the method is get. If I submit a form, we know it could be a get, but it's most likely a post, right? So the data is sent behind the scenes, right? We did that, we know that, right? And then there are actually a lot of other HTTP methods. They are not the only one. Let's actually take a look at this. Let's see which one would be. Okay, there we go. Here are some results. I'm going to add that to our notes. Actually, why not? All right, so the HTTP methods. There is the method get. So here are some examples of get. Get means fetch data, which is what? Retrieve, right? From the CRUD, create, retrieve, update, delete. This is the retrieve part. So get is used to retrieve data. So here's an example. You could say, if this was an API, right, you could go to /users. That should give you a list of users. /users, size 20, page 5. So probably if there's a lot of users, this would show me the 5th page, 20 users per page, right? This would give me access to user with ID 123. This would give me access to the address only of user with ID 123 and so on. Okay, so here are some examples. Now, we know in a real API, we don't have to implement all of those. We can implement only the ones we want. right? But these are some of the possibilities. So I actually have a list here. So let's take a look at this. Let's say our API was, we had students in it. By the way, it's customary to use the plural names in the API. So if I had a database table students, right, then there would be API URL /student. So if I did get /students, that would fetch all of the records, or where all means all records accessible to the currently authenticated user. It doesn't necessarily mean all the records from the database. That depends on you, the implementer of the server side, right? But it would mean, fetch me all the students that I can see, right? You could implement parameters if you want to. You could say, for example, fetch me all the students where the minimum GPA is 2.5, the name begins with BA, and show me the second page of the results, right? You could do pagination too with APIs. Yes, you could. Here, fetch me information about one student only, student with, let's say, ID 17. Okay. With a get. Okay, so before we get to that, with HTTP requests, I'll just see this one. Hopefully, will show us. No, that's too much. Let's do. I thought Wikipedia had a nice article on this. There we go. All right. So when we send things using get method, we send information in the URL only. All right, so here is an example of get. This is the get. I was saying, give me, well, the index, so /, right? I'm using HTTP version 1.1, and the name of the host is www.example.com. These are headers, right? Requests have headers, and it also may have a body, right? And then the response is saying here, yes, I do speak HTTP 1.1. The code, the return code is 200, which means everything is okay. Here are the headers of the response. Then there is an empty line, and there is the body, which is what's interpreted by the web browser. Okay. Now, get requests don't have a body. You see, it has headers. In this case, just one. Usually, there's more, right? But it does not have a body. You see in here, if I look at the, let's just see the request. Where's my request? Request headers. There's quite a few. See all of those on the right-hand side here? These are all the request headers. There's quite a few of them. Okay, method get, path, which is the URL part, and so on, right? And then there is a response with headers as well. And then there is response body. So get requests, if they need to pass any data, the data needs to be passed in the URL. That's the only way to do that. So that's why we see here parameters of whatever we're fetching in the URL. So there is no data sent in the body of, there is no data sent in the body of a GET request, but data is received in the body, which means that the result is being sent over here, right? There's a server response being sent. Okay. Now with a post, it's a little bit different. With a post, we actually can send data in the body as well. Let me see if I can find you an example of a post request. Oh, there we go. There it is. So this is a post request. It says, I'm sending data to /test demo form, and I'm using HTTP 1.1. The host I'm asking up. And oh, by the way, there's a mistake here. There should be an empty line before that one. Before this, there should be an empty line. That they missed one, because this is the body of the request, right? This is what the browser sends to the server. That's what the client sends to the server, saying, well, this is usually the form values. Okay. All right. So these are the two that we already know. So what's a post, by the way? From RESTful API point of view, post is the same as inserting or creating a new record. You guys remember CRUD, right? So get is retrieve, post is create, right? Then you have put and patch. They are actually two separate types of requests. They update a record. Usually we update a record by specifying the ID of the record we want to update in the URL. So we would say, for example, from students, let's update a student with ID 56. Now, when you're doing an update, you have to say, what do you want to update? Which means you have to send information about the fields you want to modify. All right. That data would be sent in the body, just like with the post. Right. So in the post, we send data in the body, and with put and patch, we also send data in the body. Why do we have two? There's a slight difference between the two. If you're doing a put, you generally would need to update all the fields of the record, except for the ID usually. So you have to provide all the fields of the record. And if you're doing a patch, you can update only some of them. So the patch is more flexible, right? In patch, you can say, well, there's a record that has 5 columns, 5 fields, but I only want to update 2 of them. So I could do a patch, right? If I do a put, I should technically specify all the fields that I want to update, all of the fields of the entire record. That's the difference. So generally, you can implement patch. That's probably a better idea. Then we have delete. Well, same thing as in SQL, right? Oh, by the way, so in SQL, put patch would be what? Update, right? Put patch is an update. And then delete is a delete, right? With a delete, there is no body sent, no data sent in the body because there's nothing to send, because the URL will tell us what the ID of the item is. And that's pretty much it. So I got a question here. What is the difference between deleting data from the database with get, post, delete request? Hold on. You can only delete with delete. You can't delete with those.
No, we can, but what is the difference?
What do you mean?
So in the project, we can use deleting for deleting from the database, and we can also use a post or get, and it will also delete the values from database.
No, hold on a second. So post creates a record. That's an insert. Get is a select essentially, right? So this is a select, this is an insert, and this is an update.
Yeah, but why we still can use the post method for deleting?
You can't. I never said you can. You cannot. Post is an insert of a record, not a delete.
Okay, because in the project I used, and it works.
Well, listen, if you implement a post to delete a record, that's on you, but you're not doing RESTful API if you do that.
Okay.
You can receive whatever you're receiving. You can decide, if I receive a post, I'm going to delete a record. That's your choice, but it's no longer a RESTful API if you do that. You're not, because the standard says get, fetches data, post, inserts a new record, put patch, modify a record, and deletes a record. Okay. Yeah. If you do something else, you can technically do that. Listen, I've implemented APIs before. I knew better. I implemented APIs that were doing a get, and get was causing an insert. Could I do that? Yes, I could. It was a valid API. I designed it this way, right? But it was not a RESTful API. It was not following the REST standard. Okay?
Yeah, okay, thank you.
All right. Good. So we've got, as I said, 4 operations, right? 4 operations. Then when those return, meaning what? When you get information back from the server, some of them return some data, some of them don't, right? Get definitely returns data in the body because that's where it's for. Post, it doesn't have to, but it could return some information. It could return, for example, the ID of the newly created record. That's not a bad idea, right? Put, patch, they don't have to return any data. They could, but they don't have to. And delete, neither. It doesn't have to return any data. Okay. Now, whether those operations succeeded or failed is actually given to the client by the means of HTTP code. You guys already know them, right? 200 means success. Everything is okay, right? 400 anything means client's at fault. 500 server is at fault, right? We already know those. We don't do the 100s, and 300s won't happen because that's a redirection. So we don't need 100s and 300s for RESTful APIs. So here is a couple of oddities. So 200, which means what? Which is the usual, everything is okay, is returned by get, put, patch, and delete. 201, however, is returned by post. They made it a little bit different. They actually said, listen, when you create a record, we will return to 201 instead of 200. Why? That's just the design of it. It still means everything is okay. It's just the code is slightly different. Okay. The explanation that I found for why they do it this way is, think about it this way. If you do get multiple times, does the content of the database change? If I do get once or 5 times, does it make a difference? No, I'm fetching the data once, I'm fetching it 5 times, no difference. If I'm going to do an update with the same data, if I update once versus I update 5 times, it's still going to be the same result. The first update will update and the rest will actually not really do effectively anything. What I mean is that if I repeat the same update 5 times, it makes no difference whether I do it once or 5 times. The end result will be the same. The record will be updated, right? If I delete a record once, or if I delete it 5 times or attempt to, the first delete will delete it and the others will not do anything. By the way, just like in SQL, you see in SQL, if you attempt to delete a record that doesn't exist, what happens? Nothing. It's not an error, right? If you say delete from blah, blah, where, and it doesn't delete any records, it's not an SQL error because you did not want those records to exist. They don't exist, right? And it's the same way in RESTful APIs. If you attempt to delete a record that does not exist, the API will say, success, you didn't want the record to exist. It doesn't. No problem, right? Okay. However, the post is different. Why? Because if you do an insert of data once, you're going to create 1 record. But if you do an insert 5 times with the same data, you would actually create 5 records. So the number of requests actually matters more, so to speak. Okay, that's the explanation I found. Why did they differentiate between 200 for get, put, patch, and delete versus 201 for post? That's the explanation that I found. Okay, then 400 client at fault. Now there's a few reasons for it. There is just the 400 bad request. So for example, let's say your API requires some additional parameters that were not provided. Your API must have them, otherwise it cannot perform the query, right? If the client did not provide the information, then that's a bad request. Also, if the information is wrong, for example, GPA, if they say GPA minimum, if they say 2 WO, right? Well, that's not a number. So that would also cause a 400 bad request code, right? Because I cannot parse this GPA. It was supposed to be numerical, right? It wasn't. Okay, next, 401, authentication with basic method missing. HTTP protocol has an authentication method called basic, which is commonly used for authentication with HTTP APIs. And that is something that we use, for example, for mobile devices a lot. We're using the basic method of authentication. So 401 means to call this URL, you must provide a request with an authentication. If you make a request with no authentication information in it, it is rejected with 401 code, authentication missing. Okay, 403, forbidden, meaning you're just not allowed to access that resource, whether you authenticate or you don't, or you change the request parameters, it doesn't matter. This URL or this data is not available to you. Forbidden access. 404, not found, or perhaps the user is not allowed to access it either. You see, sometimes systems don't show 403, which means the data is there, but you're not allowed to access it. Rather, for safety reasons, they just pretend the data is not there. They just do 404. If you try and access an item in the database that you're not supposed to, APIs will very often just respond 404, meaning it's none of your business, right? Whether it exists or it doesn't, I won't even tell you. I'm just going to say it doesn't exist because it's not yours. Let's say if you access a record that you're not the owner of. Then you have 500. Well, there's just one here, 500, which means internal server error. So if I'm making a call to an API and there is an internal error, maybe the SQL query broke. maybe I can't connect to the database server. Maybe there's some other issue inside of my server side. I will return 500 saying, I'm sorry, internal server error. Okay, so these are the codes. Okay, so let's start implementing one. So do this with me. We're going to create a new project. So let's do file, open folder, and let's create, we are on day 10. So day 10, to do rest. Day 10, to do rest, and then select the folder, right? And we're gonna have to bring in some things from the previous solutions we had. So I'm going to do that with just a file explorer. Yeah, it will be faster this way. So in here, I'll just go to XAMPP htdocs IPD23, and we're gonna borrow Slim auctions. Yeah, I think that was the latest one we did, right? The Slim auctions is the most advanced we had. So from Slim auctions, I'm going to borrow a few things. I'm going to borrow, I need git ignore, I need htaccess, and I need composer JSON, and that's all. Yeah, that's all I need for now. Okay, so copy those three: git ignore, htaccess, composer JSON. So I'll do copy, and I'll paste them into to the rest right here. Okay, so once you do that, if you go back to VS Code, you should see them right here. All right, so now that we have those three, let's do this. So we'll need to install vendor. Let me just double check here. So in the composer, we've got Slim, we've got MicroDB, we've got, we won't actually need Twig. You know what, we can, yeah, turn off the, so remove Twig and from composer JSON and remove the Slim Twig view. And then remember to remove, there's a comma here at the end, right? The last item of a list in JSON doesn't have a comma, so make sure you remove that. So we've got Slim, MicroDB, and Monolog are the only three we will be using. No Twig? Yes, no Twig. Why? Because the client will be pure HTML. We will not be generating the client from Twig, because it's not that we couldn't, it gets confusing. I've done that a couple of times, long time ago. I think I was teaching at McGill, very similar course to this, and people got confused. They weren't sure what's the server, what's the client, because it was confusing. So because this is the first time we're doing it, we're going to create client as a pure HTML file. So actually, let's just do that now. So in here, just create a new file and call it client.html. Yeah, just like that. Client HTML. Okay. Good. All right. So now, we said composer JSON. Yeah, composer JSON. We save this. Is there a warning there? Missing proper description. Yeah, we don't care. All right. So now let's install those libraries. Those three libraries only. Oh yeah, the name is teacher IP. Doesn't matter really. Yeah, nobody cares what the name is. It's only the required that we really care about. All right. So let's go to terminal. Let's do new terminal. Make sure you are in the directory of day 10 to do rest. You must be in there. Not IPD23, but rather the day 10 to do rest. And let's do composer install. Enter. There we go. Right, so the vendor was created, right? We've got Slim, MicroDB, Monolog, and some other things. Okay, about, well, we have 8 packages or so. Yeah, we're good. Okay, so that part worked. Now for the client side, we're going to take care of that, I think, tomorrow, right? So don't worry about it just yet. We're going to set up the server side of things too, because we need that. Now for the server side, we're going to have to cut some of the parts off. So you know what I'm going to do? I would open our slim auctions index. Let me just check that. Hold on a second, because we did cut it to, yeah. Okay, so I actually, in my case, I need init, but in your case, you probably need the index. So here's what we're going to grab. We're going to grab, so we created, yeah. So in here, we'll create a new file. Let's call it API. So new file api.php. And inside of it, we're going to need, let's just see which parts we need. So we'll need the logger. We'll need the require once. We need the logger. So let's borrow those, copy. We don't have a session, so no, we won't be uploading that to our hosting, so we don't need that part. We do need the database handler though. Yeah, we do. We actually need that. So the DB handler, yeah, we'll grab that. We'll have to modify it though, but yes, that will be okay. So let's paste that chunk. Where's this? And let's clean this up a little. Don't need that. Log first. Yeah. Okay, so that's what we have. And then what do we need? For the config, add content length details, display error details. Yeah, I suppose. Yeah, I think that's a good idea. So create the app. We need that. And then we don't have the twig, so none of this. We're not enabling twig, so no. Not found handler. We'll actually need it. We'll need to re-implement it later, not yet. Well, but we will need it, yeah. And then we don't have flash messages, so no, we don't need it. So the last line that we need is up run. There we go. Can I copy that into the chat? I suppose. So we need to fix a few things. So let's create logs. So in here, not a file, but folder, logs. Because we'll have logs. Things will go wrong, I can guarantee you that. So we'll need to have logs. And then vendors, okay. We don't have templates, so we don't need the template cache. We don't need the templates folder because we don't have those. We need to adjust htaccess though. You see, instead of giving all the requests to index.php, we'll give them to API.php. So adjust.htaccess. Change this to API.php. Please don't remove the space in front or after. Right, please don't do that. That will break it. Right, it has to be API.php wherever was the index.php before. Okay, let's check git ignore. You can always have more things in git ignore than you need, but never less, never fewer. So yeah, I won't touch it. It's okay. There's nothing wrong with it. Okay, good. So our API PHP, let's see what else we need to fix here. Logs, that's good. DB handler. There's this line here that renders the twig. Let's remove that. And see that line that says get environment. Yeah, remove that. And then we're going to die with a message that says fix me DB error. Yeah, because we'll get back to that. I just can't explain exactly what we need to do, not just yet. Okay, and the rest I think should be okay. Yeah, we're good. Yeah. All right, so now we have the API, and make sure there is app run at the end, right? I'm sure you have it. And let's add some calls. So we're going to start with just fetching basic data, but to be able to do that, we need a database. So go to your XAMPP control panel, MySQL admin. And let's create a database for it. So go to user accounts. It's a funny thing when you want to create a database, you don't go to create a new database, you create a user, right? So go to user accounts, add the user account, and we're going to create a day 10, what do we call it? We call it to do rest. Yeah, day 10 to do rest, local only, generate password and create database with the same name and grant all privileges, right? Please don't forget the first checkbox. Okay, we need to copy the password into our oh, see, hold on, something's missing here. I just realized, where is our database set up? Okay, we have to add that. Just a sec. How come it didn't show up in my init? Did I miss it? Maybe I missed that one. Oh yeah, okay, right, because I didn't copy it. Guys, we need this chunk. So let's just add that. We'll need to put it somewhere here. Yeah, right here. So we'll have DB name is day 10 rest. User is day 10 to do rest, and the password is, well, whatever was generated in here. Let's do it one more time. Copy and paste, and the rest stays the same. All right, so next, let's scroll down here. Again, please make sure you select the first checkbox, right? Scroll down, go. That should create a database. And then in it, we're going to create one table called to-dos. To-dos. And we'll give it ID, of course. Let's see. To-dos should have task to do, due date, so by when should be done, right? And then is it done or not? I think that's a minimum to-do list, right? What it is, by when, and is it done yet or not? Right, so ID is an int, task would be varchar, let's do 100. Yeah, it's okay, 100 is okay. Due date would be just date, not date time, not timestamp, date, right? And is done. Let's do enumerations. I really like enumerations. This is something I really sorely miss in Microsoft SQL. So let's say one will be pending, would be the default, and then done. Right, so two values. Guys, you have to remove the other ones from here. You have to press the minuses, right? Okay, pending, done, and then default is pending. There we go. So notice these have single quotes around them, and there's a comma in between. This one does not have quotes, no quotes here, because it's just a singular value. So the last thing is we have to make ID auto increment. So select auto increment here for ID, and then press save, right? So ID is primary key auto increment. Save. It should be okay. There's a couple of things we might want to do here. For example, if we expect to be sorting by due date a lot or by task a lot, we probably should add indices on them, right? In the real database, when you have millions of records, you probably want an index on the task and another index on due date. I would imagine you'd probably be sorting by those values, but we're going to start with that. Okay,
Sorry,
so
I
now
have
that
a
we,
question.
yes, go ahead.
Just out of when you do AI, is there a way to start at a certain number, or I
Yes,
have to do?
no, there is. Why
There is.
would you want to?
Oh, just we were just wondering to put some because we have account number or something, so we were just thinking like that.
So when you export the database, you're going to see that there is when a table is created, and if a table has auto increment, there is a way to set the initial value to a higher number.
Okay, okay. I will do it there then. Okay.
The reason why it's done this way is because, for example, if you've inserted a bunch of records already in the database, so let's say you have records ID, the highest ID is, let's say 10, then the next ID after you import the database needs to be 11, not 1, right?
Okay.
But you can only, yeah, so you're going to see when you do an export of this table, you're going to see that there's going to be a value, the initial value for auto increment in there. But normally we don't touch it. There is no need to.
Okay.
Yeah. All right, forward. So now we got the connection information. We still have to fix a bunch of things here, but we'll just get straight to doing a get. Right. We'll see how that works. So guys, for the purpose of our APIs, we're going to use JSON to carry the information back and forth. We could have used XML, we could have used something else, but JSON is the easiest one to use. PHP has a great support for JSON. It's very easy to use it with PHP. And since the client will be JavaScript, using JSON is the most natural way to go, because JavaScript obviously supports JSON very well, because JavaScript, well, uses JSON, right, internally. So we'll do that. We're going to use JSON for our API. So let's first implement one call. Let's do a get of to do. So we're gonna do, see how that works out. Let's do this, and then, okay, so now to do that, we don't have to add using, hold on a second. We'll need, just a moment. So we just added those two lines here, the use for response and request, right? And now this should, the error message here should disappear. So what I want to do is I want to do a query that will fetch all the records that I have, right? So I should probably, just for testing purposes, go ahead here, and I would say I should insert at least 2 records just so I have something to fetch. So let's do that. So I'll say ID, I don't know, buy milk 2%. Due date, let's say tomorrow, right, is done, is, no, it's pending. All right, so there'll be 1, yeah, sure, and then go back to insert again, and I'll say dig out the car. I'll probably gonna have to do that, maybe even today. This one is also pending. And then insert book a hairdresser. Actually, I just did that yesterday, finally, so that one is done. There we go. So I got 3 records. There we go. Just so I have some data to play with. Okay, so we were just about to create the first API call, which was the /todos, right? And yeah, that's exactly what we're going to do. So we said we need to do a query, right? So we'll do db query, and I'm fetching multiple records, so just query is fine. So select all from to-dos, right? I could do order by, I don't really have to. And let's say this would be, that's my to-do list. That's my, so let's do list, yeah. So that's my to-do list. And then an interesting thing. So what we want to do is we want to translate the list into JSON, right? The way JSON looks as a list, so JSON list example, okay, they have this thing called arrays, right? So what we want to translate JSON into essentially an array of associative arrays. Because that's what we're getting here, right? We're getting here a list, which is what? Array of records, right? And then every entry in that array is an associative array of key value pairs, the keys being the names of columns and the values being the values, which is pretty much exactly what we need for the API. So what we're going to do, we're going to translate that information into JSON. Now you guys already saw me. Let's try this one for a moment. use print R for debugging purposes. So it's a little similar. Don't do this one. Yeah, this is just as a part of the demo. Okay, so I'm going to try and access this. Oh, hold on. We should add. I just realized we need to add Apache configuration. Yeah, let's do that one. Guys, so fire up your Notepad as administrator. You guys remember Notepad as administrator? Yeah, start it up. As an administrator, right? And then open, we have to go to C, Windows, System 32, drivers, etc. There we go. And then switch to all files, right? Switch to all files, and there's a file called host.txt. Please never create this file. It is already there. Okay, so C, Windows, System 32, drivers, etc. And then switch to all files and open hosts. Okay, like you did before. And let's just add one more here. So we'll do 127.0.0.1. And we'll do, what should we have? We'll do day 10 to do rest, right? That's what it was. Yeah, to do rest dot local. That will do. That will do fine. Okay, good. So save the file. Yeah, make sure there's at least one empty line at the end of the file. Always don't leave it like this. That sometimes messes things up. So add one more or more empty lines at the end. Save the file. Close Notepad, and then let's configure XAMPP. As before, we'll go to config httpd.conf to the end of it. Right, make a copy. And let's just adjust that to day 10 to do rest, and then day 10 to do rest. Save it, close, and then stop Apache, start Apache. And now if I direct my web browser to this address, I have to, unfortunately, you have to put http:// in front because most browsers will not understand the top level domain local. So that's why. Site can't be reached, connection refused. Okay. Oh yeah, right. Colon. Yeah, because we're on 8888. There we go. Okay, so if you're seeing what I'm saying, that's good. That's exactly what should happen. See where you guys are with that. So as I said, we should see this kind of page not found, which tells us that PHP Slim was working properly, right? That's just because we did not define the slash, the index.
I couldn't see this one. I did.
All right, so now we're about to see what's going to happen when we access /todos. Now, this is just because we used print R before. It's not really the correct solution just yet, but the API would be under /todos. Right, you see, when I access this, I get the information. Now, the thing is, this is exactly the information I want, right? I want an array of associative arrays, which are all the records I'm fetching. It's just, this is not JSON, right? It's not really, it's more of a human-friendly, believe it or not, this is supposed to be human-friendly format. What I want is JSON, which is actually really easy to do, because all I need to do is to use something called JSON encode, JSON encode. Right, so we're going to do just that. So in here, and you can do this one with me, we're going to do, let's just do JSON equals JSON encode of list. That's pretty much it. Now, in regular PHP, in pure PHP, we'll just echo, right, to print out the contents. But because we are in PHP Slim, we need to use response, right? So what we're going to do, we're going to write this JSON, which is just a piece of text. Okay, let me just show you. Don't do this one. But the idea is that you would essentially get this. It's not well. Let's do view source. There you go. Right. That's what I would get. Right, which is JSON right? Array containing 1, 2, 3 associative arrays in it. Now what I what I want is, I don't want to echo it because that's just not the proper way to do it in PHP Slim, right? No echoes, but rather I want to use the response. So the way to write it is, you can do this one with me, response get body write JSON and return response. Right, that's the way to do it in PHP Slim. Let me show you what this does. It actually, the result is the same. It still prints out, right? But that's the proper way to do it. One last modification we'll do is that I want pretty print. You see, this is not exactly user-friendly in terms of the design. The computer doesn't care, but since I'm developing the system, I actually want it to be written nicely. So I'll add a second parameter to JSON encode. I'm going to say JSON pretty print. There you go, this one. And when I do, it will change the way things are formatted in the source code. Now the display is still messed up, and I'll get to that in a moment, but I just want everybody to get to the point where you can see that. All right, so we got the result in the web browser. Now it doesn't quite show the right way, not exactly. Now here's the problem. You see, in the view of the source, it seems formatted kind of the right way, but when I'm viewing it in a web browser, it's not quite. And the reason for that is because we're actually telling it that this is HTML. Believe it or not, that's what's being sent, because by default, PHP Slim or PHP actually will say that the content type, look, it says it's HTML. Well, I disagree. It is not HTML. It is what? It is actually is JSON. Right, so what we need is, we need to find out content type for JSON. Actually, there's a few of them, but the one we want is usually this one, the application JSON. That's the content type that we want. We need to tell the web browser that we're sending it JSON. Okay, and the way to do that is to tell PHP Slim that that's the type we're sending. Okay, and I'm just looking at my notes here. There we go. So the way to set this up is, we need to tell it somewhere. We could actually put it as the first line here. We need to tell it that this response, so response, just hang in there. Yeah, response. Yeah, it's best to do it the first as the first. Response is response with header, and then we need to give it name of the header is going to be content dash type. It's not case sensitive, but it is typo sensitive, so just careful. It has to be exactly content dash type, no additional spaces or other characters. It's not case sensitive though. And then the value of it will be, and we could copy it from here too. It will be application JSON. That's true, but we're also going to say semicolon char set will say that this is UTF-8, because that's what it is, right? Because we are sending UTF-8 there. So once I do that, I'll be back in a sec. But let's just refresh this. All right, so once I do that and I refresh, you see now it shows up properly. Why? Because now we've informed the web browser that the content type is application JSON. You see, so now the web browser knows, oh, it's not an HTML site. Oh, I didn't know, right? Because previously, if it thought that this was an HTML website. Okay, guys, I'll give you that in the chat window actually. So this line will have to happen for all of our requests, right? Now, I do remember there is a way to tell PHP Slim to, instead of using HTML, text HTML as a default content type, you can tell it to use application JSON as a default content type, but I would need to check documentation. I don't have that in my notes, unfortunately. But I know there is a way to do it, to essentially say everything I'm generating is going to be application JSON, which is what it should be. Okay. So that's that part. Okay, good. So we got the get working. That's nice. So to create a record, we're going to use post. So let's just go with this. Let's make a copy of how much of this we need. Let's just copy the first two lines, change this to up post, and let's just close this. Yeah, there we go. That should do it. Okay, so do that with me. Now this one is more tricky because in this case, if we look at what we learned today about, let's close this, close that, about APIs, RESTful APIs, is that this one needs to receive data from the client. So we need to send it data. Now the way this is done, yes, it's a post, but we can't really do that from a form, not really, no. We actually will need a different tool to be able to test our APIs, because yes, we can do a get from a web browser, maybe a post, but not really. But doing a put, patch, and delete, no, that's not going to happen. There is no easy way to do those from a web browser. I'm not saying there isn't, but there is no easy way to do that. So we're going to install a tool. So for this, you need to be using, you can be using Firefox or Chrome. I recommend Chrome, is usually the de facto standard. And let's go to Chrome RESTful extension. And there's going to be two of them. There's Advanced REST and there's Postman. Yeah, which one was better? I've used them both, actually. Okay, it looks like Postman is more popular, so we're going to go with Postman. It has higher rating too. Yeah, so go with Postman. And I think in Firefox, I don't know if Postman is there, but you definitely have the advanced REST client. So one of those two. But Postman would be preferred because that's what I will use. Okay, so add it to Chrome. Say add the app. And then launch the app. By the way, in the future, if you want to see your apps, when you open a new, actually it doesn't show here because I have this thing, but yeah, we'll get there. All right. So launch the app is going to launch a new window. And you're going to say, take me straight to the app. I'll create an account another time. We really don't need to create an account. There's no need to. See, there is a link here at the bottom. Just click on this one. I mean, if you want to create an account, that's fine, but there is no need. Postman Chrome is Postman app. No, that's okay. No, just close this. We don't need that. Yeah, this is fine. Close again and then maximize that window. Okay, by the way, in the future, when you want to access your apps, the way you do that, you open the apps. You see there is Chrome : apps. Also, when you open a new tab, in most cases, there will be an icon here on the left that will show you all the apps. Okay, that's the way you access it next time. Okay, Chrome apps, if you need to type it up, you type it up, right? Or you open a new tab. It's just, I have this kind of a gadget here which covers the newly opened tab, but normally here on the left top you should see a link to see all the apps. Okay, and if it doesn't work, then you can always use that. Okay, so let's go to this one, Postman. So what we're going to do, we're going to test the get that we already implemented, the previous one. So what I want you to do is just to grab the URL that you had here, which was the day 10 to do rest local / to-dos, right, on port 888, and just paste it here, right? The method is get, and just press send. That's all we want to do, right? And what you should see is the output over here. Unfortunately, I didn't find a way to make the fonts bigger, so we'll just have to deal with this the way it is. So now that we can do a call to view the to-dos in our tool, why do we need the tool? Look at this, because this tool allows us to issue any of those type of requests. Now, most of them we won't be using, but the ones we need are here. There's post, put, patch, delete. See those? And there's a reason why they are first, because they are the main reason why this tool actually exists, so that we can use it, for example, to test RESTful APIs. Okay, so now go to post. So switch to post. So what does post do? It creates a new record, right? It creates a new record. So if you just go and send it, right, you're going to get some sort of an error here, well, like this, for example, right? The reason being that we actually, let me just go to the editor, because I didn't save my file. Actually, that's the main reason. I didn't actually save the file. So if I save the file, run it again, I get nothing because I didn't actually print anything out here, right? Not an error, I don't get any errors, but I get no actual output, okay? So now, post is when we create a record, which means the client, which is what? This tool, right? The postman is the client at this point. Client needs to send us a record to create. And the way this is done, you see there is two sections here. Well, there's three sections really. There's the URL we're accessing. The second section over here is the request over here, right? And then the bottom part is the response, right? That's how this is structured. So over here in the request, not response, request, we need to click on body, and then we're going to say raw. Raw means we can just type up anything. We'll be sending text with the request. Just like, when you're doing a get, you're receiving text. Now we're going to be sending text in the body of the request. So we're sending it from the client to the server. That's the direction, right? Now, what's the text? Well, we need to send a definition of a record. So what I want you to do is grab one of those. So go to your web browser, grab one of those, but only the curly open to curly close, only that chunk. See, without the comma, just one of those. So curly open to curly close, copy it, because that is an associative array that defines a record. Okay, and then we'll remove the ID. Why? Because in our definition of the API, ID will be assigned by the server when record is created. Okay, now this is not a requirement by RESTful APIs. I could have decided it differently, and sometimes people do. But in our implementation, it works just fine, because when I create a record, that's when the task receives an ID. So that actually works out fine for me. Okay, so I'll say, let's just see, let's just do some tasks. When I'll take a walk, right? Because it's actually beautiful and sunny today. Due date today is good, and pending. Yeah, I'm okay with that. Okay, so you can modify it slightly just so you know it's going to be a new task. Okay, and then press send. Now, nothing will happen really because we're not handling it yet, but that is the text that we want to be sending. Now, what do we do with it on the server side is the bigger question. So on the server side here, what we need to receive are the values to receive. Now, we already learned about a lot of versions of how to receive values. We know we can receive values as parameters of the get, right? From the get, we can receive values from a post. We've done those, like when we're submitting a form, right? We know that there could be arguments in the URL here as well, can they? Right? Yes, we know. We know that in here I could have arguments for it. So we already know about a few ways of receiving things. This one is different. We've never had that before, because we will be receiving data in the body of the request. And the way to do that, we actually need to ask. We need to ask the request for the body. So do this with me. We can say JSON, because that's, so what we're going to get will be a string. Hold on. What we're going to get will be string containing whatever we send here, text, right? We're going to receive that text. So we're going to say JSON request get body. And that's going to give us the text, a single string with whatever was sent, right? Now, string is just a string, but what we really want, we want the values. We want to know key value pairs. So what we want to translate that string we're seeing here into key value pairs. So this is what, that's the key, that's the value, that's the key, that's the value. We want an associative array of key value pairs. We want to reverse what we did here. You see line 58 over here, I did JSON encode to take an associative array and turn it into JSON. Now I want to reverse the process. I want to take JSON, piece of text, and turn it into an associative array. The way to do that is to do JSON decode, and we're going to give it JSON as parameter, and what we're going to get back is going to be, well, the item, the to do. or what should we call it? The record? Yeah, let's call it the record. Okay. Now, when we do it this way, what happens is the JSON encode actually has two modes of operation. This is a little tricky, guys. By default, JSON decode creates an object. Gregory, we didn't talk about objects. I know we've been using them. We haven't actually created any objects. So we haven't quite addressed it, but we really have. Guys, all of these are calls to methods, right? They are. So we've been using object-oriented programming. We haven't actually maybe created our own classes simply because we had no need for it, and we usually don't, right? But we are using software that is all object-oriented. So what we want to do here is we want to get back an associative array. But the thing is, JSON decode by default, it creates not an array, but creates an object. Why is it done this way? Because you see, in JavaScript, an object and an associative array are the same thing. In JavaScript, an object and an associative array are the same thing. You see this thing I see here, this, in JavaScript, that's an object with fields, task, due date, and is done. And it is also an associative array. It's both. In JavaScript, it is the same thing exactly. But in PHP and most other languages, we actually have two separate things. We have objects and we have associative arrays, and they are two complete different creatures. Separate, right? So what we want to do is we want to tell JSON encode decode that we want to get an associative array and not an object. And the way to do that, you give it a second parameter, true. You must have it. So you're going to add true. And what it does, it makes it return an associative array instead of an object. You see, I could have just given you the code, but I want you to understand why these things are there, because there's a lot of details here to make it work. Once you see the code, it's going to be pretty simple, but why is complicated. Okay. Now, once we receive the record, why is it actually? Oh yeah, it just says I declared that I never used it. Okay, I was just wondering about the color. So now, once I receive data from the client, guys, I can never trust the client. So what I would need to do, I need to validate that information. We're not going to do it just yet, but I will put a to-do, validate the new record to be created. Okay, guys, I'm going to change the record. Sometimes bothers me. Can we just do item? Okay, so we have just, yeah, let's just do item. For some reason, the word record just bothers me in this context. I don't know why. Because it's not a record entity. Yeah, it's not an entity. I need a better word for it. It's not an object yet either, definitely not. Data. Now, let's just call it, yeah, item. Yeah, let's call it item. Okay, so we're going to have a to-do to validate. To validate it. We're not going to do it just yet, but what do we need to validate? Well, quite a few things. First of all, does it look like we received everything? Did we receive the task? Did we receive the due date? Did we receive is done? What if somebody says, well, I should reject that, right? That should be rejected. There is no color in to-do, not in my definition, right? Also, what if some data is missing, right? What if somebody did not provide a due date? I also need to reject it. So I mean, so it's not a goal, it's not a to-do, it's a dream, right? You're dreaming about taking a walk because there is no due date, right? You'll do it someday, right? Anyway, joking aside, I require fields to be exactly what they need to be. I should have no more fields, not fewer, when I'm creating a record. Secondly, I will have to validate the contents. I will have certain requirements. The task probably shouldn't be empty. And I also know that my varchar is 100 characters long, right? This needs to be a valid date in a specific format. This needs to be either pending or done. So we will have to do validation, not now, but we will have to do validation for a complete system. Okay. All right, good. Now, for now, we're going to assume, we're going to take it easy. We're going to assume that the item is valid, and we're just going to go ahead and assume that it is. Okay, so we'll need to do an insert. So how do we do an insert? Well, we just do db insert into todos, right? The values from the item that we received. And one more thing I would want to do is I would like to respond. Actually, I would like all of my API calls will send a response of some sort. And the main reason for it is that I know from previous experiences, our client will be written in JavaScript. Somehow JavaScript doesn't like it when a call doesn't return any value. So we will have to return values from all our calls, even though technically it's not a requirement. So what I will do here is I will ask for what the insert ID was, and I will give back I will send back this information. Return is not exactly the right word necessarily, but I will send back this information in the body of the response. So I'll do response. We said get body, so just like before, right? I'm gonna write what? Write the insert ID is actually what we want, right? We want to send back in the body of the response. Guys, we have two bodies here: body of the request, that's where we're receiving, and then body of the response, which is what we're going to be sending. I'm going to write out the insert ID, and this one I should do technically on everything I send. I should do JSON encode. Now, in this particular case, it will make no difference whatsoever because I'm sending an integer value, and integer value is just itself, so there's no modification done. But technically, whatever I'm sending needs to be a JSON, because I promised. Look, I'm saying here content type that I will respond with will be JSON. So I need to make sure this is JSON, and return response. Right, I'm almost good here. There's just one check missing. According to the API specifications, when I do a post, I need to return 201. The default HTTP code is 200, so I have to amend it. I have to change it to, let's just do that. Hold on. Yeah, I have to change it to response with, what was it? With status 201. There we go. Okay, let me test it and I'll get back to the code in just a moment. So now if I do the post, let's try this, see if it blows up in an interesting ways. Send it, and it didn't. I got a 4. You see at the bottom here, that was the response. I got 4 in the body of the response. And if I go to my database, see a new record was created. Take a walk, right? Number 4, pending. Okay, good. All right, guys, I'll give you a minute or two to make it work and test it here. Actually, let's add one little thing here. I want to log it. You know what? Just for the fun of it, because we haven't used the logs yet. Let's log information a record was created. We don't always need to do that, but in this case, it's a kind of a good excuse. So here, once I did the insert, so after here, I'll add a log, and that's a debug type of information. So it's a log debug, a record todos added with ID. I like sprintf here, actually. We'll see. ID, yeah. ID is dot insert ID. You guys remember concatenation in PHP is using dots, not pluses. Please do not put a plus here. It must be a dot. Okay, so once I insert a new record, let's just try it one more time. So I say finish rud methods today, again, and pending, right? And I say send. So I create a record number 5, right, which would show up in the database, of course. But the interesting thing is, in my logs, see, in the everything log, there is an information here, record todos added ID 5. So implementing delete will be your homework. So how do you implement delete? Well, you're gonna have to have app delete of to-dos slash, and this needs to be an ID, right? So you're gonna have something like, because we say in the URL, right, for delete, there has to be an ID right here. Okay, so you're gonna implement that. So to this, I'll give you the initial, the first piece of the code. It's not complete. You don't have to finish it, but it will be ID. We'll say, well, it's going to be numerical, right? And then function and so on, right? So you, yeah, like this. That's one. And then the second thing I want you to implement, so that's one. Also, get of a single record. There we go. So these are the two that I'd like you to implement. And of course, and test it. Right, those two.